Hello once again and welcome to the 17th episode of Simply Electronics Basics. In this episode, we're going to go through the basics of soldering, from how to get started with your soldering equipment, straight down to the soldering technique itself. Now, I need to mention, you really should solder in a well-ventilated area, preferably with a fan, to blow all of the fumes away. With that mentioned, obviously, the first thing that you need to start soldering is a soldering iron. You don't actually need to spend a lot of money on a soldering iron. You can buy soldering irons for very reasonable prices, not just in the hundreds of pounds or dollars range. This soldering iron in front of me is actually a soldering iron originally manufactured in China and cost me a total of £30, or around $40. If you've seen soldering irons before, you've likely seen two types. This type, which is a temperature controlled soldering iron, and the type of soldering iron, which is just a soldering iron that plugs in directly to the mains with no temperature controls. Personally, I prefer a temperature controlled soldering iron because I need to vary the temperature of my iron depending on what I'm soldering. If I'm soldering sensitive components, I really want to take the heat from the soldering iron down to the minimum possible. But when I'm soldering larger connections and less sensitive components, I might want to ramp the temperature right up to 450 degrees Celsius. For most applications, I like to set my iron to about 380 degrees. The first thing that we need to talk about with soldering irons is how to keep the tip clean. A clean tip of a soldering iron is very important to ensure that you get the best solder connection. This soldering iron is currently turned on and hot. However, I applied some solder to the tip of the iron, but it's now dried out because all of the flux from the solder has evaporated. This has now left dry solder on the end of my iron. It is important that you regularly clean the tip of your iron to ensure you have a clean surface as much as possible, increasing the quality of your soldering and conductivity of the connections. When you have a soldering iron, you should have a wet sponge that you can clean your soldering iron on. This iron holder has an area for a sponge, so I've slightly wet this sponge. Make sure your iron is hot, and the only thing you need to do is give the iron a few wipes on the sponge. As you can see now, the tip on this iron is clean and ready for fresh solder. The best kind of solder, if you can get a hold of it in your country, is lead-based solder, usually 60-40, 60% tin and 40% lead. Personally, I find lead-free solder to be very difficult to solder with. Lead-based solder makes easier connections and flows way easier than lead-free solder, so my iron is on and up to temperature. If I apply the solder directly to the tip of the iron, you can see it melts straight away. That's because the soldering iron is above the melting temperature of this tin and lead alloy. Now you can see the smoke coming from the iron. That smoke is just the flux inside the solder. Flux is a very small core inside the solder which helps to clean surfaces as you apply the solder to a component or connection. If you still have solder on the tip of your iron and it's not smoking, all of the flux has evaporated. In this case, I would need to clean the tip of the iron again and reapply solder to the end of my iron. Applying small amounts of solder to a piece of metal is called tinning. When you tin by applying thin layers of solder, you are essentially cleaning and preparing a surface and priming it for a good connection and easier join. Because the flux evaporates from the solder so quickly, it is important that once you have tinned your iron and any other component, that you solder them together as soon as possible to ensure that you get a good connection and to prevent dry solder joints. So make sure you clean the iron with a sponge regularly and re-tin the tip of the iron as much as possible. Now, it's very difficult to solder with just two hands because you need to hold a component, the solder and a soldering iron. So, these little things are called helping hands, and there are many different variations of them. These helping hands are basically crocodile clips attached to a metal stand that can hold wires and components for you. In this case, I'm going to use the helping hand to hold this perforated prototyping board. My goal is to solder an LED onto this board. So what I'm first going to do is put the LED through the perforated holes, slightly part the legs of the LED to prevent them falling out, and attach it back to my helping hand. So now I want to solder these legs to this board, now that I have a clean tip on my iron. After tinning the soldering iron, I apply the soldering iron directly onto the component lead and the copper pad that I want to solder it to. I then proceed to apply the solder to the pad and the component lead but not directly to the iron. Because both the copper pad and the lead of the LED were up to temperature, the solder flowed onto them easily. It is important that you don't use more solder than is necessary. A good solder joint looks like this, creating a nice concave shape. You can see what has happened here. I've used way too much solder, and the solder has actually melted and made contact with the other side of the LED. This is not a good joint. Now, let's say I want to join two wires together. In this case, I'm going to strip the ends of my wire to expose the connections inside. So I've taken a small portion of insulation from the end of this wire, exposing the copper wire inside. I need to do this with both ends so that I can join them together with solder. So it's going to be difficult for me to do this with just two hands, so I need my helping hand again. I've put one of the wires in the helping hand. Now what I need to do is tin the end of this wire to ensure that I can get a good and quick connection. So I'll tin the iron, apply the iron to the connection, and then apply the solder directly to the wire, not the iron. So I now have two tinned ends of wire. The only thing left to do now is join them. So what I'm going to do is prepare the end of my iron by tinning it, hold the two connections together, and apply the iron on top of them. And there we go, we have a perfect join. If I now try to pull these wires, they shouldn't break easily. Now, I should mention that when you have an exposed joint like this, it's important that you cover it up and re-insulate the wire. If you were to use this wire in a circuit, it is prone to causing a short circuit, so you should always ensure that exposed connections are re-insulated. The best way to do it is to use heat shrink, which is a form of plastic that you can slide over a wire and over a joint to re-insulate it. When you apply a small amount of heat to the heat shrink, it shrinks around the joint to create a secure insulation. So I hope you learned a little bit more about how to solder from this video. If you would like to keep up to date with the latest videos from Simply Electronics, please make sure you subscribe to the channel. Give this video a thumbs up if you enjoyed it, and leave your comments below.